One day there was a fire in a wastebasket in the office of the Dean of Sciences. In rushed a physicist, a chemist, and a statistician. The physicist immediately starts to work on how much energy would have to be removed from the fire to stop the combustion. The chemist works on which reagent would have to be added to the fire to prevent oxidation. While they are doing this, the statistician is setting fires to all the other wastebaskets in the office. "What are you doing?" the others demand. The statistician replies, "Well, to solve the problem, you obviously need a larger sample size." And here we are on talking about getting random samples. So we had some experience in the previous lesson dealing with getting random rectangles that we were working with, and we used a random number table to do that. How do we draw random samples in general? Well, let's look at a prize drawing. So in a prize drawing, let's say I'm giving out sodas to half the students in my class. And I start alphabetically with the roster. And I say, okay, I'm going to flip a coin. If you get heads, you get the soda. If you get tails, you don't get to the soda. And I go until I run out of sodas. Who is most likely to object to this plan? The kids with the last names near Z, because they're at the bottom of the roster. The probability that I'm going to make it all the way down and still have some soda left is not so good. The probability of the first couple of people are going to get a soda is like 50-50 compared to the people at the bottom. So what's the way we normally draw for prizes in a class? Well, we tend to use like a box or a hat, and we put the names in. So this is the gold standard for drawing a simple random sample. You put all the individuals. So I would take each student, put their name in the hat. Now, if I had said, written their names down, put them in the hat alphabetically, and just started to draw, someone might object. Usually, you want me to mix them well. So that's a very important part, so we can introduce this randomization. Then I would draw until I got all of my sample, or winners if it's a prize drawing. Now, one thing, if I'm drawing, let's say I draw Abe's name first, then I put his name back in the hat. What would people say? They go, wait a second. You're only supposed to draw them once. And for samples, we're only supposed to draw them once. So if you put the name back in the hat, you need to ignore repeats, all right? One way you can avoid that is just leave the name out of the hat. But if you're using something like computers or calculators, they will have some repeats in there. So it's always good to say ignore the repeats. After that, you would survey every individual that you drew, and that would be your sample. This is often called the hat method. And why is it preferred for random drawings? Because all outcomes are equally likely. No one is more likely to get selected than someone else in the hat. Now, we don't always use simple random samples, and why would that be? Well, there can be some challenges in getting simple random samples. If I wanted to sample all the students at the high school, even though I'm a teacher, it's difficult for me to get a listing of everybody due to privacy issues. So maybe I wouldn't do a simple random sample of all the students in the high school. If I was trying to do all the students going to prom, the problem is I don't have a list of students going to prom. I could actually take a list of people who had bought tickets and sample them, but that wouldn't give me everybody going to prom because, some people wait till the last minute. Customers at a grocery store, that's even worse. They're moving around, and I definitely don't have a list. That would be a difficult one to sample randomly using an SRS method. Trees in a forest, we could do it. I could map every tree and number every tree or name it some unique identifier, and then I could put them all in a hat and draw them, but that would be a real pain. So again, the simple random sample is the gold standard, but next I'm going to go over some of the different random sampling techniques because of these challenges. One favorite way to survey is with clusters. So we're going to use the image at the right here to come up with a definition for a cluster. If you look at the groups, there are groups of people here, another group, a group, a group. What would a cluster be? Well, a cluster is a group, really, And it doesn't mean that the group has to have everything in common. Now, this one looks like everybody has something in common. You could almost say these people have something in common, but there's a mix really. So clusters are really just groups of individuals that are located near each other geographically or in some other way. Maybe it's a texting group or some other type of cluster where they're all together in some spot. So what's an example of a cluster in a high school? It would be a classroom, a bus route, everybody together on the bus, neighborhoods, anytime you have groups put together. Now, the way you would draw a cluster sample is what you do is instead of putting the individuals in a hat, you put the cluster names in the hat. And then don't forget to mix well. So we mix the cluster names in. And the clusters could be like classrooms. So my classroom right now is D231. And you could have D232, 233, 234, 235. Throw them all in a hat and figure out which classrooms we're going to sample. So we put all those rooms in the hat, mix well, and draw until we get our sample. Now, as always, ignore repeats for samples. And then here's the difference with a cluster sample. With a cluster, what you're going to do is you're going to survey everyone in the drawn group. So if I pull room D231, I'm going to go ahead and actually survey everyone in D231. All right. Now, why would we prefer this to a simple random sample method? Well, it may be much easier to identify and sample clusters. If I were to have you go into school and say, oh, get me a simple random sample of all the high school students, that means you have to get all the names, throw them in a hat, draw, and then go find those people to survey them. It's way easier to find a classroom. It's like right there, it doesn't move. So cluster samples are one of the most popular ways to do sampling. Now, I'll do a quick example with the two methods. You're going to survey students seated in the cafeteria. How would you do a simple random sample? Now, I actually did do a survey of the cafeteria in the spring. And what I did, I could have done a simple random sample. And if I'd done that, I would basically number every seat in the cafeteria, have some sort of unique identifier. Then I would put all those seat numbers in a hat, mix it well, and draw seat numbers without replacing to avoid repeats until I get however many people I want to survey. Then I would survey the people in the selected seats. Now, I didn't do it that way. Why? Because the seats kind of move around and it's very hard to get a listing. And not only that, the population here would have just been seated students. And I'm okay with that. But it's very difficult because the seats can move around. So how would you draw a cluster sample in the cafeteria? That's actually what I did. So instead of numbering the seats, the one thing that doesn't move around very well are the tables. So I numbered the tables, threw them in a hat, mixed it well, and then drew my sample. So I basically went to each table then, and I surveyed every student at the table. That way I went up to him, I said, your table has been randomly selected for our survey. And everyone is invited to do the survey. And so those are cluster samples. My clusters were the tables in the cafeteria. Again, a very good and convenient way to sample if there's no reason to think that there are differences between one table and another. Now, another way we can sample is something called stratified sampling. If you look at the image at right, what would you say a strata is? Well, here's one strata, another, 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 and another. You can see that each of my groupings are alike. They share something in common. So strata are groups or classes in a population that share a common characteristic. In high school, that would frequently be by grade level, because freshmen and seniors tend to be slightly different creatures. Trust me, seniors do not want to be confused with freshmen, or sophomores with freshmen, or juniors with sophomores for that matter. Another way you can do strata is ethnicity. So if you're concerned about, minorities, you can also do it by socioeconomic if you're worried about income level. So there are different things that you can look at and group people based on strata. Sometimes certain strata don't make sense. For example, in the summer program that I'm teaching, I have kids from Austin AISD, Round Rock AISD, Leander, etc. I could separate them by school district, but that wouldn't really be as meaningful because there's no reason to think that an Austin kid is that different from a Round Rock kid or a Leander kid. So that sometimes strata makes sense, especially for grade levels, things that would create common characteristics in the group. So how do we set up a stratified sample? Well, if you look at the picture at right, these are the steps for doing a stratified sample. How does this picture look different from my other pictures with the hats in them? Hopefully you notice there's more than one hat here. It's like I'm doing a simple random sample in each strata. Each strata gets its own hat. All right, each strata gets its own simple random sample. So we set up a hat for each strata. In each hat, we're going to put not the strata, but the individuals. So we have, we could do the freshman hat and the sophomore hat. So the freshmen go in the freshman hat, sophomores go in the sophomore hat. And after we do that, mix it well. Draw until you get the sample you want for that strata. Ignore repeats as always. And after you get the individuals from each strata, go ahead and survey everyone that you pulled from the different hats. In this example, we have a hotel with 8 floors and 30 rooms on each floor. It has 96 rooms facing the ocean and another 48 with a partial ocean view and 36 facing inland. Room numbers have the first digit from the floor number, and the next 2 digits range from 1 to 30 for each floor. Rooms facing the ocean cost the most, partial ocean views the next, and inland rooms the least. What strata could you use? Well, I could go by floor number, right? But is there really a difference between a person who gets a hotel room on a second floor and a third floor? Not really, all right? Probably if I wanted to group like-minded hotel stayers, I would put the people who are willing to pay a little extra for an ocean view in one group, and the people who want to save their money and have the inland view in another group. And of course, the partial view would be the compromisers. They'd be in the middle group. So don't use the floors because there's no difference there. Use the room view type, all right? How could you draw a stratified sample? Well, I would have set up a hat for each view type. Ocean hat, a partial hat, and an inland hat. Then I would put I wouldn't worry too much about this first digit from the floor. I would just basically take all the floor numbers, all the hotel room numbers, and put them in the appropriate hat if they have an ocean view, inland, partial view, or inland view. Mix for each strata for the ocean hat, mix it well. And then I would draw room numbers without replacement till I got the desired sample size because I want to ignore repeats. Then I would also draw samples from the partial hat and the inland hat. Now, if I was drawing samples from these, one thing to keep in mind would, let's say I wanted 20, all right? If I wanted 20 rooms for my sample, how would I draw it from the different strata? Well, you could say, well, let me roughly divide by a third. I would get, say, 7 with the ocean view, 7 with the inland view, and 6 with the partial view. Well, that might be okay, but I don't have an equal number of rooms of each type. They're actually different proportions. So one thing I could do is look at the percentage of the population that I want to sample. All right, so 240 total rooms, I want 20. So I roughly need 1/12 of the total sample size. All right, a little over 8% in case you're interested. So I would take 1/12 of the ocean views and I'd sample 8 rooms. 1/12 of the partial, which is 4, and then 1/12 of the inland and sample 8 rooms there. This strategy is called proportional allocation. Sometimes people are moving around or your individuals are moving around so much that you really can't pin things down and do clusters or stratified sampling. There's still another technique we can use that includes a little bit of randomization to give us to avoid bias. And this technique is called systematic sampling. Now, if you look at my graphic here, what do you notice? I have what looks like a line of individuals. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What am I doing? I'm sampling every 10th person. So a systematic sample is a sample created by selecting every nth individual. So you go skip every so many. When might we want to do a systematic sampling in a high school? Well, lunch lines is a perfect example. You can also get students coming in and out of a certain area, so like the library would be a great place to do a systematic sample. Now, how do we do it? Where's the randomization involved? Because if I say every 10th, doesn't that automatically tell me who I'm sampling? Well, there's still something we can randomize. So first of all, you do get to pick the frequency, or how many different, how many you go till you skip, or how many you skip, I should say, the frequency that you want to use to sample. Ideally greater than 10, and I'll tell you why in a future lesson. Here I use 10, and that's okay. Now you're going to put the numbers 1 through n. So if you decide to sample every 10 people, you're going to go 1 through 10. If you do every 15, 1 through 15. You put them in the hat, and of course you mix it well. Then you draw the starting point. That is what is randomized. You do not automatically start with the first person you see. Then you would sample every 9th individual from that starting point. So if you wanted to survey every 20th person in the lunch line, how would you select your sample? Well, you put the numbers 1 through 20 in a hat and mix well. Draw one number to select the starting point, and then select every 20th person. And that is a systematic sample. It has a little bit of randomization. Now, there is a sampling method that is used the most, which shouldn't be used the most. In fact, this is the one type of sample you should avoid because there is no randomization. Now, if you recall from our previous lesson, when we used convenience or judgment, our estimates of our parameters were actually more biased than we used randomization. So what does it mean when you do a convenience sample? It's like, oh, let me just go ask these people. Or let's say I give you an assignment to do a survey and say, well, I'll just ask the people in my statistics class. Convenience samples are convenient, and if you don't feel like working hard, you tend to do them. Unfortunately, you're usually wasting your time. If you leave customer satisfaction surveys in the lobby of a hotel, you're asking for bias, all right? I promise you, the people who are on the hotel aren't going to bother to spend their time to fill out a survey. People who are really happy might, and people who are really upset might. So again, avoid convenient samples at all costs. So what were the big ideas from today's lesson? Well, we talked about simple random sampling, cluster sampling, stratified sampling, systematic sampling, and the horrors of convenient sampling. The statistician's wife had twins. He was delighted. He rang the minister, who was also delighted. Bring them to the church on Sunday and we'll baptize them, said the minister. No, replied the statistician. Baptize just one. We'll keep the other as a control. And we're learning about control groups and experiments, and we're talking about designs of studies today. So, one of the things we need to know about, one of the first steps in a study, is to know who the study is about. So determine what population you want to study, and then determine if you can do a census or just need to do a sampling. A lot of times if you can get everyone and do a census, that's great. But there are times you don't want to do a census, like, say, for a blood test. We don't want all your blood. All right, step 2, what do we want to know? So you need to formulate questions that will help you gather the data. Remember that the questions won't always be just like what your result for the study is. So for example, the percentage of people who have internet access, you would be asking instead, do you have internet access? Not what percentage of you have internet access. Now, questions or interviews that influence the outcomes can lead to bias. So I made this little cartoon here. Before I grade your tests, please complete this survey on my teacher performance. And they all check thumbs up. Why is that? Well, they don't want the teacher to be upset while he's grading their tests. Questions should be objective. You can also do leading questions that can give you response bias. And remember that interviewers should always be courteous, ethical, and protect the anonymity or privacy. That helps minimize bias as well. So in this class, we almost never do a census, and we don't deal with censuses because they're just too difficult or too expensive. And so instead, we look at ways we can get random samples. Now, most of the time, you will need to sample, and you'll have to determine what method you're using. The sample frame, which is where you're picking the people or the subjects out of, is the pool of possible participants in the sample. If there are individuals in the population who are not in the sample frame, this results in undercoverage and can lead to bias. So, for example, let me say I was looking at different respiratory systems, and I'm like, I don't like to get my feet wet. And I look around, and I'm walking through the forest and over the ground, and I capture different animals for my sample, and I look at their respiratory systems. Well, I'm going to be leaving out the animals that live in the water, and they tend to have gills and other types of respiratory systems. And so my sample would really not be representative of the entire animal population. So examples of bad sample frames can include timing, such as surveying on senior skip day. If I want to know prom ideas, don't do it on senior skip day. All the seniors are gone. Or if the person's not home. So, for example, I go knocking on doors during the workday, but I'm trying to interview people about their jobs. Undercoverage occurs when we cannot get the survey to the target because they are not in our sample frame. So in the first example with the animals, I'm experiencing undercoverage for animals in the water. If I'm looking at surveying about prom and I survey about senior skip day, I'm leaving out a bunch of seniors. If I survey people at home during working hours, but then I'm leaving out people who are currently at an office. Now, be sure to use randomization in your study. If you let individuals volunteer, this is not random, and it is likely that they won't be representative of the population. So, for example, I could do a survey in the cafeteria about, say, hey, should we have a new baseball field? And who's going to come up and answer the survey? People interested in baseball. Most people who aren't interested in baseball aren't going to be bothered. So when this happens, we call this voluntary response bias. And non-response bias, which is different, occurs when we try to give the survey to the target, but they refuse to do it. So it's good. It would be not a good idea to use a method that is easily ignored, such as mailers, email, phone calls. To minimize non-response, you would prefer to do in-person surveys. So one of my favorite ways to do surveys is to go to the cafeteria and I give them the survey. So it's very hard for them to throw it away, although that can still happen. So most surveys will suffer from non-response bias, but we try to minimize that. All right, so let's go ahead and look at a couple of examples to bring this all together. So for each of the following, we're going to determine the sampling method, the sampling frame. You might have to guess on that, the sample, and the possible sources of bias. We have 2,000 adults are surveyed about their confidence in the U.S. economy. Surveyors selected 500 people randomly in each of the 4 U.S. time zones using driver's license registration. So the population, they're trying to do confidence in the U.S. economy. So they're actually looking at all people in the U.S. economy. See how they say U.S. economy. The sample frame, well, who are they asking? Registered drivers in each time zone. So the sample frame is pretty much registered drivers in the 4 U.S. time zones. By the way, who are they leaving out? Under coverage would be Hawaii, Puerto Rico. Those are all parts of the U.S., but they are not in those time zones. Well, actually, Puerto Rico is probably in that time zone. Not sure if they included them. The sample is 200 selected drivers, and the method is stratified. The reason is they're getting a small sample from each time zone. It's like they're doing 4 hats. A hat for Eastern time zone, for Central, for Mountain, and Pacific. So that's your strata. Now, where's your source of bias? Well, besides leaving out Hawaii, which is probably not going to be the end of the world, they also still have under coverage because people who can't drive may be more likely to be unemployed and less optimistic about the economy. Let's look at the next example. The CRS, the Cedar Ridge Cafeteria, wants to check student satisfaction with food quality. So they leave customer satisfaction cards at the register, and you've seen things like that, and where the students can just choose to pick it up and fill it out. And they receive 124 comment cards. Well, what's the population? Well, they're probably trying to get at all Cedar Ridge students. The sample frame are students who go where the sample cards are displayed. So who are they leaving out? Honestly, a lot of seniors who are going off campus. So we definitely are going to have an undercoverage issue here. So the sample is the students who return the cards. The method is convenience. This is not random at all, which automatically disqualifies it as a good study. Sources of bias. So voluntary response bias, and I should have actually put under coverage as well. Voluntary response bias because only people who feel strongly enough to take their time during lunch to fill out a card are going to do that. What kind of people are going to do that? People who really like the food and people who really hate the food. So you will have more extremes. And we also leave out all of those people who do not see the cards. Either they don't go into the cafeteria or they just don't see them. All right. Now, you could argue with student satisfaction with food quality, they're not too worried about the kids not going. But if they wanted to know how to make their menu better, then they are leaving out those kids who don't go to the cafeteria. Okay, in this example, every student in 4 elementary schools is interviewed about their ability to access the internet. They chose the elementary schools at random from 11 different elementary schools in the district. So the population are elementary students in a school district. Sample frame, every school had a shot. So for this survey, it's the 11 elementary schools. The sample is all the students in the 4 elementary schools who responded to the survey. The method is cluster because we're doing all from some. And the source of bias, well, first of all, assumes that all elementary schools are similar to the general population, so you might have some issues there. You might have some non-response bias from kids who are absent. But other than that, it should be okay. But a stratified sample might be a better strategy here because if you get all of your 4 schools from areas that have higher socioeconomic, they may have more internet access. Although lately the trend tends to be the other way. The higher socioeconomic wants their kids to have less technology access, not more, believe it or not. But I'm sure the higher socioeconomic still has internet access. So last but not least, sampling error versus bias. So we've been talking about bias and what's the difference between that and sampling error. So sampling error is just natural variability in samples. It's not a bad thing. Bias, which is like the response bias, the undercoverage, that's when we're off from true values because we're leaving something out. So this is biased with little sampling error, or little variation. This has little bias or no sampling error, lots of bias and sampling error, and little bias because it's close to the true, but still lots of sampling error. Honestly, we love this. We're still pretty happy with this on the right. We do not like either one of these, okay?